Yeah, test.
Well, we have
One
tests.
other test.
See, there's no detail because you can't when
All right. Good afternoon. So the new due date for homework 10 is Friday. Friday afternoon. You can drop it in my mailbox. I'll pick it up. So any question before we start? We have exam on Monday. So you can bring one sheet as a question sheet, both sided. No question from kinematic synthesis, velocity, acceleration, and force analysis.
No synthesis?
Are we getting a practice exam?
No, but I can post the sample.
That's fine.
I'll post without solution. I just post
Yeah. Yeah,
the exam will be on Science Center Hall. We start at 1:10. 1:10 to 2:10. Yes.
So for the velocity and acceleration, can you give us the distance analysis so we can start from there, or we need to start from the very beginning?
You don't need to calculate for displacement analysis, but if I ask you to derive the velocity equation, then first you have to write the displacement equation and differentiate the displacement equation to get the velocity equation. That part you should be able to write the vector loop equation.
So that's all we're going to do? No computation?
No, I'm not asking you to do any calculation for displacement part. So for example, if I give you a 4-bar mechanism to do velocity analysis, I give you the angle, input angle theta 2, I give you theta dot 2. I'm not asking to solve theta 3 or theta 4, but I may ask you to derive the velocity equation. To do that, then you have to write the velocity, the displacement equation and differentiate to get the velocity equation. But I give you theta 3 equals to, for example, 42 degrees, theta 4 is 110.
But when it comes to like getting a value for the velocity or acceleration,
You should be able to solve it. I may ask you to calculate. Pardon?
So this is exactly
This one is too easy for you. I already asked you for the homework. All right. So we started kinematic synthesis with analytical approach for 4-bar mechanism with 3 precision points. So we would like to design or synthesis this mechanism, this 4-bar mechanism, such that it generates this set of desired hash. When link 2, it's moving from first precision point to second precision point by the angle of 30. The output link should move from the starting point, which is P1, to the second precision point, and that angle should be 90. And when it's moving from first precision point to the third by 45, we would like this link is moving by 120 degrees from first to third. We assume D equals to 1. We solve for A, B, and C. If this is theta, this is beta, and this is theta. Everything is starting from the governing equation that we derived for vector loop equation. So A cosine of theta plus B cosine of beta equals to D plus C cosine of phi. And y equation is going to be change cosine to sine, and we can repeat this equation for 3 precision points. First precision point, second, and the third. So 3 times 2 is going to be 6. We get these 6 equations. Every 2 equations is corresponding to each precision point. I equals to 1, I equals to 2, and I equals to 3. Then we wrote all angles with respect to the first precision point. So the first 2 equations are for first precision point, I don't touch them. But second one, I have theta 2, I'm writing theta 2 as by using this equation. Theta 1, 2 is theta 2 minus theta 1. So theta 2 is going to be theta 1 plus theta 1. So for angle of theta, beta, and theta, I'm doing this. And for theta 3, we are using theta 1 plus theta 1, 3. Theta 3 is theta 1 plus beta 1, 3. And phi 3 is phi 1 plus phi 1. So we don't have any phi 2, beta 2, and theta 2. We only deal with first precision point and difference between first and second, first and the third. So we end up to these 6 equations. The first 2 for the first precision point, second one is for the second precision point, and third one is for number 3. So the value, if I look at them, A, B, and C are unknowns. These one, so I put it as a noun. Theta 1 is unknown, beta 1 is unknown, and phi 1 is unknown. The location of or the angle of link 2 and 3 and 4 at the first precision point. Also the orientation of link 2. Beta 1, 2 is unknown, beta 1, 3 is unknown. But theta 1, 2, theta 1, 3, phi 1, 2, and phi 1, 3 are known. These are the information that we would like to generate. Theta 1, 2 was 45, theta 1, 3 30, 45. P1 was 90 and 100. So we have 6 equations. We cannot have more than 6 unknowns. But if you count the unknowns, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 unknowns. We assume 2 values, 2 unknowns as the free choices. We pick beta 1 and beta 1, 3 as free choices. You will see later that in another method that we will cover tomorrow for the instant method, instead of picking beta 1, 2 and beta 1, 3, we need to pick theta 1 and phi 1. For some specific problem, we have to choose theta 1 and phi 1 as free choices. So if these 2 values are given, then we are going to have 1, 2, 3, 4, 5, 6. So we should be able to solve these 6 equations, 6 unknowns. Now in the next 2 slides, we will see how can we solve this. But let me just review this. Cosine of summation of two angles, theta 1 plus theta 1, 2, is going to be cosine of theta 1, cosine of second angle, cosine of theta 1, cosine of theta 1, 2, minus sine of theta 1, sine of second angle. Cosine of summation of two angles. Sine of summation of two angles is going to be sine of first angle, cosine of second angle, plus cosine of first angle, sine of second angle. And just, we know this, I just wrote it down because I'm gonna use these two on equation 3, 4, 5, and 6. So on the first equation, if I have A times of this, it's gonna be A cosine of this minus A times of this. So the first one is going to be A cosine of theta 1 plus theta 1, 2. I multiply both side by A, I will get this. I'm using the intermediate variable. A times cosine of theta 1, I assume I label this by P. And A sine of theta 1, Q. Second term, if I multiply, it's gonna be B cosine of beta 1 plus beta 1, 2, it's gonna be B cosine of beta 1, cosine of beta 1, 2, minus B sine of beta 1, sine of beta 1, 2. I expand this by using this equation. I choose beta 1, B cosine of beta 1 as a R, and B sine of beta 1 as a S. So far I define P, Q, R, S. Last term is C cosine of P1, P2. C cosine of P1 cosine of P1, 2 minus C sine of P1 sine of P1. I expanded that. So the first C cosine of P1, I choose T for this and U for this one. So first equation has 1, 2, 3 terms. I expanded them. I expanded this one, and this one. And I defined some intermediate variables. P is A cosine of theta 1, Q is A sine of theta 1, R is B cosine of beta 1, B sine of beta 1, and T is going to be this, and U is going to be this. And now, in each term, if you look at the other terms, theta 1, 2 is noun, theta 1, 2 is term. So this is noun. Second term is cosine of beta 1, beta 2, this guy. Beta 1, 2 is a free choice, so it should be noun. Same thing for this term. So first term and second term, the unknown term would be P, Q, R, and S. And last term, the only unknown terms would be T and U, because C is unknown, P1 is unknown. But P1, 2 is 90 degrees. So I'm gonna switch from these 6 equations, 6 unknown, to another system of equation by 6 equations, but the unknowns would be P, Q, R, S, T, and U. Let's count them. 1, 2, 3, 4, 5, 6. And solve for P through U. So let's do a class activity. This is equation 1. This is equation 4. I picked them from that system of equation that we do at 6 by 6. So write these 2 equations as a term of P, Q, R, S, T, and U. I just want to make sure that you know how to expand the terms and replace the unknowns with the intermediate variables, which are P through U. Is that clear what I'm asking? Okay, we derived 6 equations. This one was first one. These are the 6 equations that we have. Okay, I'm asking you to write these 6 equations. Replace the term with the P, Q, R, S, T, and U wherever it's needed. So for example, A cosine of theta 1 is P. So you replace this by P. B cosine of theta 1 is R. D is now is 1, and C cosine of P1 is T. So do this for equation 1 and 4. Then I'm gonna do it for the remaining equations. Number 14, Chase.
I have no clue at all.
Did you try the first equation at all?
No, I've been looking at fluids at the moment.
Okay.
To be honest with you. Good test coming up.
You have exam.
Yeah.
Okay,
I'm not
let's.
gonna lie to you.
Number 20. Mike. Number 22. Gently.
So we need to solve for.
Yeah. On the first equation, did you try it? Or you're busy with that boy?
Yes.
Probably very.
Okay, let me try. Any volunteer?
I can do the first
Yes.
one.
B plus S equals D plus T.
First one, P.
Plus S equals D plus T.
Okay, and you are at the end. What would be for the second one?
Second one, Q plus S
Q,
plus X,
S you said?
yes, equals U,
Echo,
U,
P,
U,
U, okay.
plus
Okay. Let's say, let's look at this. The first one is A cosine of theta 1. A cosine of theta 1 is P. That's fine. B cosine of beta 1 is R. It should be R. D is 1, but I leave it D for now. But when we are solving, I'm changing to 1 at the end. And T, C cosine of P1 is T. Number 4. First, you have to expand this. So A sine of theta 1. I'm going to expand it here. It's going to be A sine of theta 1 cosine of theta 1 2 plus B sine of beta 1 cosine of A cosine of theta 1 sine of beta 1 2. This is for the first step. First step has this guy, A sine of theta 1, which is Q. But we should multiply by cosine of theta 1 2. So this guy is going to be Q sine of theta 1 2. Second part has A cosine of theta 1, which is P or this should be cosine P sine of theta 1 2. Second term is, we should expand that, B sine of beta 1 cosine of beta 1 2 plus B cosine of beta 1 sine of beta 1 2. So B sine of beta 1 is S. And this is going to be R. But it should be multiplied by this. So you have S here, but it should be multiplied by cosine of beta 1 2 plus B, which is R side. R sine of beta 1 2. This is left side. Right hand side, I should expand that. It's gonna be C sine of P1 cosine of P1 2 plus C cosine of P1 sine of P1 2. C sine of P1 is U. C cosine of P1 is T. Right hand side is going to be U cosine of P1 2 plus T sine of P1 2. Look at these two equations. First equation, the only variable are P, R, T. This equation, Q is unknown, but theta 1, 2 is known. Theta 1, 2 is known. Beta 1, 2 is free choice. We are given with that. And phi 1, 2 is given, 90 degrees. So for equation number 4, P, Q, S, R, T, and U are unknown. So I'm gonna do this for the remaining equation, and I end up with this system of equation. See, on the first equation, I change D to 1 plus T, because D is 1. 1, 2, 3, 4, 5, 6. 6 equation. The unknowns are P, Q, R, S, T, and U. So if we want to solve this system equation, I need to move all unknown terms to left side, and other terms should be moved to the right side. So for example, for this one, I should move T to the left side, which is going to be negative T equals to 1. For this, I should move U to the left side, it's going to be negative U. Equation 3, I'm going to move these two terms to the left side. Do this for equation 3, 4, 5, and 6. At the end, we are gonna get system of equation with 6 by 6 matrix here, coefficient matrix A. Variables are P, Q, R, S, T, and U. First row is for the first equation, second row, this is P, Q, R, S, T, and U. So first row it's for first equation. First term for the first row it should be the coefficient of variable or unknown P, which is 1. I give it 1. There is no Q, 0. The coefficient of R is 1. Coefficient of S is 0. T is negative 1. And U has the coefficient of 0. Second equation, no P, Q is 1, R, there is no R, S is 1, T is 0, U is negative 1. Third equation, P has coefficient of cosine of theta 1, 2. So I'm just writing C theta 1, 2. Q has the term of negative sine of theta 1, 2. R has the term of cosine of beta 1, 2. And negative sine of beta 1, 2. T, when I move this to the left side, it's going to be negative. Negative cosine of C1, 2. And positive U sine of P1. I just have for the first 3 rows, you can check the third row, cosine, negative sine, cosine, negative sine, negative cosine, sine. There is no U. First 2 rows are matched. Right hand side of the equation, just look at the system equation. First equation has 1. Second equation, it doesn't have any constant part, 0. Third equation, it has 1. Number 4 doesn't have anything. Number 5 is 1, and number 6 is 0. 1 0 1 0 1 0 1 0 1 0 1 0, and the remaining terms should be written here. Now you are ready to solve this system of equation by using the MATLAB or your calculator. These angles are given or known is beta 1 2 and beta 1 3 are two sources, and phi 1 2 phi 1 3 theta 1 2 and theta 1 3 are given. So you come out with P, Q, R, S, T, and U, but it's not what you are looking for. But we know that P is A cosine of theta 1, Q is A sine of theta 1. When you have P and Q, after you solve that, you will see that if I squared both, P squared plus Q squared is going to be A squared cosine square of theta 1 plus A squared sine square of theta 1. Cosine square plus sine square is going to be 1, so you will get A square. So the square root of this is going to give me A. So A will be a square root of P square plus Q square. You find A, you find this length. What would be the location of second link at the first precision point? We are looking for theta 1. Theta cosine of theta 1 will be P divided by A. Sine of theta 1 is Q divided by A. You have P, you have A. Find two angles here. You have Q, you have A. Find two angles there. Find the matching pair. So theta 1 can be calculated by looking at P and Q. So I use P and Q. R, if you remember, R was B cosine of beta 1, S was B sine of beta 1. Same logic, R and S, P and Q. If I square both sides and add them up, I can get rid of beta 1, so I can find B. B would be a square root of R square plus S square. You find B with the same method, find beta 1. This is R and S. So you find the length of B and the angle of link 3 at the first precision point, which is beta 1. And T is going to be C cosine of phi 1, and U would be C sine of phi 1. Just repeat the same. Find C equals to a square root of T square plus U square. And find phi 1. After you find C, find phi 1 by finding the matching pair. So you find C and phi 1. So you can draw your mechanism at the first precision point. You are done with that because D is 1. So this mechanism is going to generate this desired function or desired test. And this slide just explains what I explained to find A, B, and C, and how can we find theta 1, beta 1, and phi 1. So find two answers for theta 1 for cosine, find two answers for theta 1 for sine, and find the matching. Any question on this? So for this specific problem with this given desired task, theta 1 to 30, P1 to 90, theta 1 to 45, P1 to 120, you would like to design the mechanism. I pick three choices, beta 1 to equals to 25, beta 1 to 30. You can pick any numbers. So I just pick these two. If I pick these two, I will form the matrix and find the value of P, Q, R, S, T, and U. These are, I reported these values. I got it from the MATLAB. I solved this system equation. I got P through U. Now, how can I find A? A would be S square root of P square plus Q square, 0.8911. If I do that, I will get A must be 1.02. What would be theta 1? Theta 1 would be sine of theta 1 is Q divided by A. Cosine of theta 1 is P divided by A. Q is 0.8911 divided by 1.02, and P is 0.497 divided by 1.02. It's going to give me 60.82 or negative 60.82. For the sine, it's going to give me 60.82 or 180 minus 60.82, which is 119.18. So I compare 60.82, 119.18, 60.82, and negative 60.82. So I go with 60.82. Do the same things for B. You will find P equals to 1.42. Beta 1 is this guy, and C is going to be 0.431 with the P1 negative 34. We write A, B, and C here. A is 1.02, B is 1.42, C is 0.431, and D is 1. I can ask you to draw the mechanism at the starting position, second position point, and the third position point. First, you pick O2 and O4 with the distance of 1 from O2. Then theta 1 is almost 61, pick 61. A is 1.02. You end up to this point with this angle. So this is one joint. From here, P1 is what was the P1? P1 was negative 34. See here, P1. And beta 1 is negative 52. So either at this point, going by negative 52 point something, which is almost 53, draw a line and go by this length, B, 1.42. You end up to this point. If you connect this to the O4, this length must be 0.431, and this angle must be negative 34.3. So this is the mechanism at the first position point. Then you are moving by theta 1, 2, which is 30 degrees. From angle of 61, you end up to 91. So this guy should move by angle of 90, which is second precision point. And if you move by the angle of 45 degrees from here, which is 106, this should move by angle of 120, which is this angle. It's going to represent the third precision point. Good. So, what if I ask you, this is what you need to do for, I think, on the homework. What if I ask you to design, to generate this desired function, and we would like to have crank rocker? You got these values. Is it crank rocker? First, you should check if it's a Grashof mechanism. Shortest link is 0.431. Longest link is 1.42. And P and Q would be 1 and 1.02. If I add them up, I will get 1.85, and here I will find 2.02. Shortest link plus longest link is less than P plus Q. So it's a Grashof mechanism. But shortest link is this guy. This is adjacent to the ground. So if you would like to have this as a crank, this is a crank mechanism. But if you like to have A as a crank, then you have to change your free choices. The free choices were beta 1, 2, and beta 1, 3. I picked 25, 30, yes, 30. If you would like to go with this as a crank, then you have to change these values. You can do it by hand, but it's a lot of calculation. So it's better that you use the code, the software like MATLAB or Excel to speed up the design iterations. You might be given with these different types of the criteria. I say I would like to have double rocker or crank rocker, or I would like to have non-Grashof. Then you should satisfy that. The only thing that you have is free choices. I might ask you, I would like to have mu max less than 135, for example, and mu mean is greater than 45. After you find A, B, C, and D, if it's a crank rocker, you should find the mu max and mu min. If it doesn't satisfy the criteria, you have to change these values and try it again. Or I might say I would like to have the maximum mechanical advantage be 0.8. You know what would be the definition of mechanical advantage? After you find A, B, C, and D, test the mechanical advantage, the maximum mechanical advantage, and if it's needed, you need to do more iteration to satisfy the requirement for the design.
Would we be required to show that we have done one iteration of everywhere, and then we have run another, or the
No,
final one is the only one?
that's fine if you just report the final. Any more questions on this? All right. So the next synthesis problem that we cover is function generation for an offset slider crank. So here we were given with the correlation between input angle and output angle. In offset slider crank, input angle is there, but the output is the slider. So we are given with the desired location for the slider.
Can I say something real quick about that? So, when there is like a, for example, theta 1, 2, and you draw it after you do the analytical approach, do you have to try both sides, or is it like
No.
which side is it? You
Theta
go-
1, 2 is 30.
Like
Means-
you go counterclockwise?
No, theta 2 minus theta 1 is 30. Meaning theta 2 is greater than theta 1. Whatever is the theta 1, you add it by 30.
And it's always like counterclockwise.
I'm saying it should be added.
Yeah.
If it's subtracted, you go there counterclockwise. So you go clockwise. But it's positive. If I say theta 1, 2 is negative 30, then you are going to the clockwise. That is a good question, because in this example you always see the positive number, but it might be negative. So in offset slider crank, for example, for this one, we would like when the first the crank is moving by the angle of 30 degree from first precision point to the second, then the difference between these two is 30. S2 minus S1 should be 1. So the location of slider at the second precision point minus the location of slider at the first precision point should be 1. It can be negative 1. If it's negative 1, meaning that when you go from first precision point to the second precision point, it should move to the left side. Because in that case, S2 is going to be less than S1, you get the negative value. And when it goes by 90 degree, we would like S3 minus S1 be 3.5. This is a function generation because we are given with the correlation between input angle, input link, and output link. And we want to do it by analytical approach. So look at this slide. Same as four-bar mechanism, we write the vector loop equation. OA equals to OD, BC, CA, for example. Or A cosine of theta would be S, there is no X component for this, plus B cosine of phi. S plus C cosine of 90, which is 0, plus B cosine of phi. And for the Y component, it's going to be A sine of theta plus C plus B sine of phi. And it's valid for 3 precision points. It's a 3 precision point problem. So 2 equations for each precision point. We have 3 equations. We have 3 precision points. We end up to 6 equations. These are the 6 equations. A cosine of theta 1, S1, B cosine of phi 1, and for the Y component. Then, same as 4-bar mechanism, we write all equations with respect to first precision point. So instead of having S2, I replace S2 by S2 would be S1 plus S1. I replace theta 1, 2 by and then we are going to rewrite this equation with respect to the first precision point. I'll finish it tomorrow.